Now then, this problem's not particularly difficult. It's just an old UKMT question from 2010. So the question is, if x squared minus px minus q equals naught, where p and q are natural numbers, which of the following could not equal x cubed? To start off, you wanna express x cubed in some shape or form, and the worst thing to do is just use the quadratic formula and just cube the cunt. I wouldn't do that. What I would be doing is we know that x squared equals px plus q. It's identical to say that x cubed is equal to px squared plus qx. And this is particularly useful because we end up with a quadratic, and we could equate this with a linear equation, which as a result we can compare that quadratic with this quadratic up here. It's the same x, it has the same roots. So we just go ahead and equate it. Px squared plus qx equals, let's denote them as mx plus c. I'm not doing all of them. Subtract it from both sides. It's equivalent to px squared plus qx minus mx minus c equals naught, which is equivalent to, collecting the terms, px squared plus q minus m times x minus c equals naught. And to equate this quadratic with this quadratic, I need to divide through by p, because this coefficient is 1, the x squared coefficient, that is. So it's equivalent. Since it's equal to 0, it is equivalent. X squared plus, in fact, I'm going to make a difference negative. It's the same thing, I'm just making it negative by turning it m minus q, then flipping the sign again, so it's a double negative, just to make things a little bit easier, because it's the coefficient in here is already negative. It's a negative of a positive integer, times x minus c over p equals naught. And straight away it's obvious that c over p is equal to q, and m minus q over p equals the p. So it's equivalent to say that m minus q equals p squared, and q is the c over p. So m minus c over p equals p squared. And now we've actually got a depressed cubic, because we've got a pm minus c equals a p cubed. There's no p squared term, which defines a depressed cubic. And having to solve this particular equation with the cubic formula, you'd end up pretty depressed yourself. It's pretty nasty. Your masochist approach. You have to use trial and error. You just have to exhaust all the possibilities. Start with a. So rearrange. This is equivalent. P is obviously non-zero. It's a natural number. Although it says up here it's a positive integer. 0 is an integer, but it's not really positive. It's neutral. So I say positive integers are equivalent to natural numbers for the sake of this video. So p cubed is equivalent p cubed minus pm plus c equals naught. So it just now substitute the values. So it's 4 and a 3. So p cubed minus 4p plus 3 equals naught. It's quite clear that p equals 1. Has an integer solution. If it didn't have an integer solution, we'd have problems. It would, we need the p to have we need the p to be a positive integer, otherwise it would contradict the question. It just shows that x cubed won't be able to equal that if it wasn't an integer. We've shown that it works. It's fine. Let's move to the next one. So p cubed. What is it? 8x plus 5. So it's p cubed minus 8p plus 5 equals 0. And I just know, because I've checked it, that this is the answer, because there are no integers, so integer values of p such that this holds 0. You can just check with Wolfram Alpha, but not in an exam. In an exam, they'd expect you to exhaust all the solutions. You'll find that you'll have nice easy solutions like p equals 1, or maybe p equals 3 for one of them. I can't remember. And you'll be left with this one, which is the only one that doesn't have the. If all of these have integer solutions, A, C, D, and E, it's implied that B doesn't have integer solutions from the question. Otherwise, it's a stupid question that we know solution over the given options. I'll show that in Wolfram Alpha. You can see that there are no integer solutions. And that's about it. It's quite an easy problem, really.